Hello viewers, welcome back to another section of my tutorial, and I have a problem in AC theorem, and this is under finding the RMS value of an AC current or voltage. So in our first question, it says we should find the RMS value of the current defined by the expression I of t, which is equal to 3 plus 10 sine of the expression 314t plus 60 degrees plus 12 sine of the expression 628t plus 80 degrees ampere. So you have to express this waveform, which is a current, AC current, and a sinusoidal. So we have to express it into, or we have to find its RMS value. So to do that, when you have waveforms of different frequencies, where the frequencies are, let's say when the frequencies are harmonic. So from here you can see that this one, it has no frequency. Here had 314 and here had 628, which is a multiple of this. So we can see that this is a harmonic. So from here what you're going to do is that you find the RMS of each wave or each harmonic. So each waveform here, you find the RMS, and after we find the square of all of them, we add them and you find the square root to find the RMS value of this expression. So let's see, this one is a constant or it's a DC value, so it's the same thing we're going to use. So what we are going to do is that you make our solution, then you make our big square root, and within the square root we have to write the RMS of each component of this harmonic. Then after you square them. So for the third part, you use the 3 because the frequency is 0 and it's constant. It's a DC part. So you have 3 squared plus. Now, to find the RMS of this is simply the amplitude over root 2. The amplitude over square root of 2. So you have 10 over square root of 2, then all squared, plus finally we have 12 over square root of 2 all squared. So here we are going to get something like square root of 9, 100, 10 square will be 100, this will be 2, so you get 50, plus this will give us 144, and here will be 2, so you get 72, and this is equal to, so square root of 9 plus 50 plus 72, and that will give us square root of 131, which is also the same as 11.446, and since it's current, we make it amperes. Now let's see the second part of this tutorial, and for the second part we have calculate the RMS current in amperes of a circuit with the total impedance to be 50 ohms and supplied from a V of t, which is a voltage source, which is equal to 2 plus 15 sine omega t plus 3 sine 3 omega t plus 10 degrees source. So how do we go about this? We have to find the RMS current, but we have been given the impedance as well as the voltage source. But the voltage source is in a harmonic form. So we have to find the RMS of this voltage source, then we use it with the impedance to get our RMS current. So this is from the expression, we have the expression V RMS is equal to Z multiplied by I RMS. So to find the I RMS is simply equal to V RMS over Z. So right now we have to find the V RMS. So if you have this waveform, and the waveform was given by 2 plus 15 sine omega t plus 3 sine 3 omega t plus 10 degrees. So having this waveform, we can see that here the frequency was 1, here is 3. so it is a harmonic. So to find the RMS is simply taking the square root of the square of the RMS of each component of this harmonic. So the 2 is a constant is a constant voltage supply, so you're going to have 2 squared plus, here we have 15 over root 2 all squared. Now it's because if you want to find the VRMS, is simply the amplitude over square root of 2 for a full wave, so that is this, plus here we're going to get 3 over root 2 then all squared. So this will be giving us square root of 4 plus 225 on 2 plus 9 on 2. So we punch this entire expression and we see what we get after evaluation. So you get 11. So the answer is 11 volts. So our VRMS of this waveform is 11 volts. So we simply move to finding the IRMS. So our IRMS will be equal to our 11 over 50, where the 50 is the impedance from the question, and this will give us 0.22 amperes. So this is the end of my video. Thanks for watching. Kindly like, subscribe and share.